Good morning, everybody. Today we're going to be doing day 2 of solving quadratics using inverse operations, and we're going to be using a new thing called Edpuzzle. So hopefully this will work out well. You're going to answer 4 questions in between the video, and we will be good to go. So let's see this first question. Follow along with me, and you're going to answer the second question when we get to it. So we're going to solve. The directions should say solve, and we're going to leave all answers in simplest radical form. That means you're not going to be getting a decimal. You're rarely going to use your calculator except to find maybe some factors. So we're going to solve is the direction. So let's go through this. So when we have x squared equals 16, we're going to take the inverse of squared, which is going to be the square root. So we're going to take the square root of both sides. And if you remember, whenever we take the square root over an equal sign, it makes it plus and minus. So we're left with x equals, because remember the x is by itself because it cancels out the squared and the square root, we're left with x equals plus or minus the square root of 16. Well, we know the square root of 16 is a perfect square, so we're left with 4, and we're left with plus or minus the square root of 4. Now, you can write it as plus or minus, I'm fine with that, or you can just write it as 4 comma negative 4. Either one is fine. I think sometimes we get lazy and we write plus or minus 4, but be careful when we get to problems where we have to put the terms together. So please try x squared equals 100 right now and answer the question. Okay, so now we're going to do square root of 100. We're left with x equals plus or minus the square root of 100, which equals plus or minus 10. So the answer is 10 and negative 10. All right, let's go to something a little bit harder. We have 5x squared minus 10 equals 30, minus 2 equals 38. Follow along. We're going to now expand our order of operations. So we're doing the opposite, inverse operation. We're doing SADMEP. Maybe on the side of the paper you want to write SADMEP. SADMEP, right? So we're going to first add 2 to both sides. So we're left with 5x squared equals 40. All right, fine. So now we're going to work our way down, and we're going to do the opposite of multiplication is division. So we're going to divide by 5, and we're left with x squared equals 8. So you guys know that x squared equals 8. When we take the square root of it, we're going to be left with x equals plus or minus the square root of 8. Is 8 a perfect square? No, it's not. What perfect square is in 8? 4. 4 times 2. So we're left with plus or minus 2, the square root of 2, and that's what x equals. Try the next question on your own. Okay, so let's do this one together. So we're going to subtract 2 to both sides. We're left with 3x squared equals 54. We're then going to divide by 3. We're left with x squared equals 18. We then take the square root of both sides, remembering that we're going to have plus or minus. We're going to have x equals plus or minus the square root of 18. The square root of 18 is not a perfect square, but 9 and 2 are what makes it a perfect square. So we're left with x equals plus or minus 3 radical 2. And we're done. All right, next one, let's get a little bit harder. Now we have in parentheses a problem. The reason why it starts getting harder is because we have to be careful of this plus or minus business. Let's go through the first question. We have parenthesis x minus 2 squared equals 25. Remember, with SADMEP, we would do subtraction first, but the subtraction is in parentheses. Parentheses is all the way down here. So we have to do, first we have to get everything away from the parentheses. We can't do the subtraction yet. So we actually are going to go first to step, which is the exponent, or sorry, the exponent. So we're going to take the opposite of the exponent, which is going to be the square root, and we're left with x minus 2 equals plus or minus the square root of 25. The square root of 25 is a perfect square, so we're left with plus or minus 5. Okay, now, fine. So now I'm going to add 2 to both sides. Here's where it starts getting tricky. We're left with x equals plus 5 plus 2, and x equals minus 5 plus 2. You cannot leave it as plus or minus 5 plus 2. That's sloppy. It's not right. You got to clean it up. So we're left with x equals 7 and x equals negative 3. Okay? Make sure you break them up so the plus and minus don't get, too easy with that. Try the next question on your own. Okay, so let's do this together. Take the square root of both sides. We're left with x plus 4 equals plus or minus the square root of 9, which is plus or minus 3 because 9 is a perfect square. Then we're going to subtract 4 from both sides. We're left with x equals, now I'm going to write out plus 3 minus 4, and minus 3 minus 4. So our final answer is going to be negative 1 and negative 7 is what x is. Final set of questions is going to be the hardest ones. I'm going to have multiple steps, and we're going to have probably things that might not go down to a nice perfect square. So let's go through the first question together. We're going to add 7 to both sides because with SABMEP, that's what we do first. And we're going to be left with parenthesis x plus 5 squared equals 48. Next step would be the exponent. So I'm going to take the square root of both sides. I'm left with x plus 5 equals plus or minus the square root of 48. Is 48 a perfect square? No, it is not. So I have to think about what perfect square is in 48. Certainly I know 4 is, but the biggest perfect square that's in 48 is 16. So I'm going to do x plus 5 equals plus or minus square root of 16 times 3. 16 comes out. We're left with plus or minus 4 square root of 3 equals x plus 5. Now, I'm going to get x by itself by subtracting 5 to both sides. Here is where we have a weird part. We're left with x equals, I cannot put negative 5 together with 4 radical 3. They don't go together. They're not like terms. Radical 3 is never, it's almost acts like a variable. So I'm going to be left with x equals negative 5 plus or minus 4 square root of 3. Why did I write it that way? Because we normally put the radical last. It's kind of like we would do with an x. So that's how it goes. So try this last question on your own. Okay, so now that you've answered it, let's see if we have the right answer. We're going to subtract 10 from both sides. We're left with x minus 3 squared equals 28. I take the square root of both sides. I'm left with x minus 3 equals plus or minus the square root of 28. Is 28 a perfect square? No, it's not. That equates to 4 times 7. The 4 comes out. We're left with x minus 3 equals, we're left with plus or minus 4 radical, I said 4, I mean 2, radical 7, okay? Square root of 4 is 2, left with radical 7. Now I'm going to add 3 to both sides, and my final answer is x equals 3 plus or minus 2 square root of 7, and I'm done. I can't do anything else. You guys have a wonderful day, and come to me to office hours if you need to. Bye now.